Hi and welcome to my physics class. So for this week, we'll have the Introduction to Physics for Engineers. So this learning material is now available on your learning management system. So this material includes topics such as units and measurement, trigonometry, scalar and vector quantity, vector component, and vector addition and subtraction. So, since physics is a quantitative science, we'll have a lot of computations and calculations in this subject. So, with that, we'll have some review of these prerequisites before we proceed to the first topics in physics. So, first, let us have units and measurements. Under this, we have the unit prefixes. So, these prefixes is a decimal system in which all the units of a particular quantity are related to one another by factors of 10. So, I suppose you are already familiar with this. So, for example, we have 1 kilogram. So, we have the gram as the base unit. And by using the prefix kilo, we know that 1 kilogram is equal to 10 raised to 3 or 1,000 grams. So, the same for 1 centimeter. So, we have the meter as the base unit, and by saying 1 centimeter, we are pertaining to 1 over 100 or 0.01 meter. Now, let us proceed to the basic units in the metric system. So, let's differentiate measurement, unit, and quantity. So, for example, I'll say that the length of this stylus is 15 centimeters. So, the measurement there is the length, 15 being the quantity, and the unit is centimeters. So, referring to table 1.2, we have the list of the different measurements. For example, the mass, time, and so on. So, for the unit, I'll discuss to you the different systems of units. So, now let's proceed to the unit conversion. So, as I have mentioned, meron tayong different systems of units. So, we have three here, the SI, the CGS, and the BE. So, SI stands for Le Système International d'Unité, or the French for the International Systems of Unit. So, under that, the length is, the unit of length is the meter, kilogram for the mass, and second for the time. So, another system of unit is the CGS, or the centimeter gram second. So, in the CGS system, the unit for length is centimeter, gram for the mass, and second for the time. And for the last one, we have the BE, or the British Standard. So, under the British Standard, the length, the unit of length rather, is in foot. While for the mass, that is in slug, and second for the time. So, for instance daw, the height requirement for a male to join the PNP is 5 feet and 4 inches. So, yung 5 feet and 4 inches, that is in the British engineering system of units. But if we are going to convert that in the SI or the CGS, we can say that the required height is 1.5 62.56 meters for the SI and 162.56 centimeters for the CGS. So let's try to solve example problem 1.1. So the problem states that the highest waterfall in the world is Angel Falls in Venezuela with a total drop of 979 meters. So express this drop in feet. Okay. Sulat lang natin. Example problem 1.1. So the problem requires us to convert 979.0 meters into feet. So, referring to table 1.3, we know that 1 meter is equal to 3.281 foot. So, for the solution, let's write 979.0 meter. So, for every meter, we have 3.281 feet. So, we'll put the 1 meter here in the denominator so that we can cancel this. And we'll write 3.281 feet in the numerator. So, you have to remember that whatever is on the denominator, i-divide natin siya dito sa kino-convert natin. And whatever is on the numerator, we have to multiply that to this one. So, now we can cancel meter. So, that would be 979 times 3.281. So, that is equal to 3,212.099 feet. Okay. So, you can try to solve practice problem 1.1. So, this requires you to express the speed limit of 65 miles per hour into meters per second. So, pause this video to try to solve on your own. So, if your answer is 29 meters per second, your answer is correct. So, how did we arrive in that answer? So, we know that 1 mile is equal to 1,609 meters. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So, we'll write 65 miles per hour. First, let us convert miles into meters. So, we'll have to put 1 mile on the denominator so that we can cancel it later. And for every 1 mile, we have 1,609 meters. And for every hour, since this is in the denominator, we'll have to put the r in the numerator here. So, for every hour, we have 60 minutes. And for every minute, since this is in the denominator again, we'll have to put the minute here in the numerator. For every minute, we have 60 seconds. So, we have the mile here, and here we can cancel that. The hour, and the minutes. So, we can cancel that too. So, what we have left is the meter per second. So, again, whatever is on the numerator, you have to multiply that, and whatever is in the denominator, you have to divide that. So, we have 65 times 1,609 divided by 60, and again divided by 60. So, we have 29.0514. That have 29.0514 meters per second. So, try to solve practice problem 1.2 on your own. You can pause this video. So, let's try to solve. Let's check if your answer is correct. So, practice problem 1.2. So, the problem requires us to convert 1.84 cubic inches into cubic centimeter and into cubic meters. In cubic meters. So, let us recall 1 inch, that is equal to 2.54 centimeters, and 100 centimeter, that is equal to 1 meter. So, you might be wondering why I put measurements of length here. Volume naman yung hinahanap natin. So, we can use this solution. So, we'll write 1.84 cubic inches. So, since volume siya, naka-cube si inch. Pwede natin siyang convert. For every 1 inch, we have 2.54 centimeter. So, we'll cube that too. I-release din natin siya sa 3 so that we can cancel it. Okay. So, what I have left is cubic centimeter. So, 1.84 times 2.54 raised to 3. That is equal to 30.1522 cubic centimeter. By the way, you can also write cubic centimeter as cc. So, for the next one, express naman daw natin siya in terms of cubic meters. So, again, we'll use this one. So, 30.1522 cubic centimeters times, for every 100 centimeter, we have 1 meter. So, i-erase din natin siya sa 3 so that we can cancel. So, we have 30.1522 divided by 100 raised to 3. So, that is equal to 3.0152 times 10 raised to negative 5 cubic meter. So, check if your answer is correct. So, we have two notes here. In any conversion, if the units do not combine algebraically to give the desired result, the conversion has not been carried out properly. So, we can check here. So, since nag-work naman yung pag-cancel natin ng units, so, it means tama yung ating answer. So, for the next one, only quantities with the same units can be added or subtracted. Meaning to say, if you have 1 meter and 1 foot, hindi mo sila pwedeng i-add. Dapat, i-convert mo muna si foot into meters or you can convert meter into foot. So, before you add two quantities, they have to have the same units. Let's proceed to dimension analysis. So, for example, we have a car that starts from rest and accelerates to a speed denoted by v within a time denoted by t. So, suppose we wish to calculate the distance x traveled by the car, but we are not sure if the correct relation is whether x is equal to 1/2 vt squared or x is equal to 1/2 vt. So, we can perform dimension analysis to determine the correct formula to use. So, first, let us analyze this one. So, x is equal to 1/2 vt squared. So, since x stands for the distance traveled by the car, that unit is in length. So, we'll write L and 1/2 is a constant. So, that means that is unitless or dimensionless. So, as for the speed v, we have L over t. Since the formula for the speed is equal to distance over time. And as for the time, we'll denote that as t. So, canceling out t, we are left with length times time. So, that means hindi consistent yung unit natin. As for the other one, x is equal to 1/2 vt. So, again, we'll have L for the dimension of x, which is the distance traveled by the car. Again, 1/2 is dimensionless. And the speed v, that is L over t. And time t. So, canceling out, we are left with L, which is consistent with this one. So, we can say that the correct formula is x is equal to 1/2 vt.